Chapter 2, Lesson 8, Literal Equations and Dimensional Analysis. A literal equation is just an equation that involves several variables and sometimes it's like a formula. So a literal equation is when we have a lot of variables that are in an equation. Usually it's some sort of a formula that we're using to solve something. And so when we talk about solving for a variable, is what we mean is to isolate the variable. So we may not be simplifying anything or really, we're not solving the equation, we're solving for a variable. So we're just trying to get that variable by itself. Let's look at an example. If I have the equation 4m minus 3n equals 8, and I want to solve it for m, that means I want to isolate the m. And so I'm going to look at this equation, I'm going to say, okay, here's an m, and that's the only m in my equation. So I have a couple things that are happening with that m. I'm multiplying it by 4, and I'm also subtracting this term of 3n next to it. So just like if I was actually solving for the variable, the first thing I'm going to do is get rid of this 3n by adding 3n. And that 3 and the n are kind of stuck together right now, and that's fine. I'm just going to add it to both sides. That gets rid of it over here, and I have 4m equals 8 plus 3n. There's not really anything I can do with that. They're not like terms, so I can't put them together. So then I'm going to say, all right, well now I'm going to divide both sides by 4. And that cancels this 4 out, and I'm left with m equals, and when we divide, we don't just divide one thing on that side, we divide the whole side. So I actually have 8 over 4 plus 3n over 4, and then I try to simplify. So I say, well, the 8 over 4, that's like 2, and then 3n over 4, I can rewrite that as 3/4 n. So m equals 2 plus 3/4 n. Let's do one more example. So if I have the formula, c equals 2 times pi times r. So it's a formula for circumference, and I want to solve it for r. So I want to isolate this r. I'm going to say, all right, I'm going to take this, and since everything is being multiplied, I can do this all in one step. I can say, well, I'm going to divide by 2 times pi, and that's going to get rid of this, and over here divided by 2 times pi. So c over 2 pi equals r. Okay, so let's do one more. 3x minus 2y equals xz plus 5. And I want to solve for x. So I say, okay, here's an x. Ooh, but now I have another x over here. So I've got a little bit of a problem. So what I need to do is I need to first get all of those x's on the same side. So I'm going to do that. I'm going to say, well, I'm going to get rid of this minus 2y, and I'm going to add 2y over here, so that I have 3x equals xz plus 5 plus 2y. So now I'm going to take this xz and I want to move it now over to this side, so I need to subtract the xz. So I subtract the xz on both sides. So I have 3x minus xz equals 5 plus 2y. So I haven't isolated my x yet, but my first thing I need to do is get all the x's together on one side. Now I'm going to kind of undo the distributive property. So I'm going to say, okay, well, I'm going to kind of take this x out of both of these terms. So I'm going to think about, well, what could I have, if I distributed an x, what would I have distributed an x to here? Just a 3. And then minus a z equals 5 plus 2y. So I kind of undistributed. So now if I think about, if I distribute that x, which I'm not going to, I would have 3x minus xz. So I just undistributed that x to get it all by itself, and now I can divide both sides by 3 minus z, and I have x equals, because those cancel, 5 plus 2y over 3 minus z. And that is my simplified equation where I solved for the x. Now let's look at the idea of dimensional analysis. So dimensional analysis is the process of changing the units, so miles, kilometers, by using unit ratios. Okay? And a unit ratio is a fraction with different units, same value. So I'll give you an example. A unit ratio would be if I put 1 hour over 60 minutes. Same value, but different units. And so your numbers are also the same. Another unit ratio would be 12 inches over 1 foot. Okay, so we're going to say, okay, let's use dimensional analysis. It says a 10K run is 10 kilometers long. So if 1 meter equals 1.094 yards, use dimensional analysis to find the length of the race in miles. So I'm going to start and I'm going to say, okay, so I'm starting with 10 kilometers. And I'm going to put it as a fraction, so just over 1. Now I need to change those kilometers into miles, it says. And it tells me that 1 meter is equal to 1.09 yards. So I'm going to say, okay, well the first thing I need to do is change these kilometers into meters. So I'm going to take these kilometers so that I can cancel them out. I put another kilometer on the bottom. And I want to change those kilometers to meters. So I put meters on the top. And then I ask myself, what's the relationship between kilometers and meters? In 1 kilometer, there's 1,000 meters. And then I say, okay, but I don't want my answer to be in meters. I want it to be in miles. But all I know is how many meters are in how many yards. So that's going to make my meters cancel. And I go up here and I say, okay, this tells me right here, 1 meter is equal to 1.094 yards. And then I'm going to say, okay, now I need to know how many yards are in a mile. Well, I know that a mile is 5,280 feet, which means that a mile is 1,760 yards, and that's going to make my yards cancel out. And now I'm left with the number of miles. But now is what I need to do is to figure out what this equals, is I need to take my calculator, multiply everything that's on the top, multiply everything that's on the bottom, and then divide the two numbers. So I'm going to take my calculator and I'm going to say 10 times 1,000 times 1.094 gives me 10940 divided by 1 times 1 times 1 times 1760, so just 1760. And then I actually do that on my calculator, and I'm just going to round to the nearest tenth, and I say, well, it's about 6.2 miles.